Hey guys, and welcome back to another video of Sparkplug. So in this video tutorial I will be showing you how to make this beautiful gear train assembly in Fusion 360. So basically this video is not going to take your very long time. Basically I will be constructing these beautiful gears using scripts pre-installed with Fusion 360, and I will be showing you how to make this assembly and how to make joints between these threads so that they move beautifully without having any intersection. As you guys can see, no two teeth are colliding with each another. So everything is running beautifully. Let me just slowly show you. As you guys can see, everything is moving beautifully. So hope you guys will enjoy. Let's get started without wasting any time. So again, this is going to be a tips and trick video. So I'm not considering any particular exact dimension. I'm just showing you how to make a simple gear train and animate this assembly. So what I'm going to do, I am going to create a 4 gears, each one with of 48 teeth, and the smaller one will be the half of it 24 and the half of it 12, and 1/3 of it as 136 mm teeth. You can assemble any one after that, it doesn't matter. So I will show you how to do this and the tricks beyond that. So let's go to new design and just go to tools, and here you have option for add scene, scripts and add scene. Click on that and scroll downwards, and we have a option for spur gear. So click on the yellow icon and click on run. Now it will ask you about the standard, remain in the metric pitch. Now here it represents the hole dia, the root fillet radius and the pitch diameter. Remember always to focus on your pitch diameter, as this is going to be a necessary element when we are combining 2 gear and making an assembly. So what I'm going to do is, first teeth that I am going to make would be of 48 number of teeth, and module, as you guys can see, module is the ratio of pitch diameter divided by number of teeth. So we have a pitch diameter here and a module here and number of teeth here. So the pitch diameter, if I just switch it to the module, the pitch diameter is number of teeth multiplied by module. So what I'm going to do is, I'm going to make the module, the first module, the module as 5. So our teeth, the pitch diameter of the first gear that we are going to make is going to be 240 mm. Rest of the thing is okay. Make the gear thickness as 30 mm, and the hole diameter, the hole at the center of the diameter, this don't have to do anything, but let's just make it 20. Now we have a pitch diameter of 240 mm here, and with the module itna and itna. And if I just press OK and wait for your system to respond, it will take few seconds to compute, and here our gear is. Now we have a gear, and you guys can see that the dotted line, if I just measure it, the dia is 240. This represents our pitch circle. Now let me just press Shift and N to enable the colors assembly. Now if I just go to history, you guys can see this is a pre-made gear but the history is there. You can anytime edit the history. Now I am going to repeat the same and make another gear of modules 5, and this time the number of teeth would be 24. Rest of the thing would be same. Now again repeat the same step again. This time the number of teeth would be 36. Press OK. Now we have our third gear, here. Now again repeat the same step, run, and this time the number of teeth would be 12, and press OK. Now we have a 4 different gear of different sizes. If I just drag them, so we have 1, we have 1, 2, and this is 3, and this is 4. Now once done, I'm going to show you how to make this gear. So before that, first of all, before making any assembly, there needs to be a component that needs to be grounded. Means, for example, here the assembly cannot work unless it is the gear are mounted or on something. So suppose that I have created this box here just to make it a grounded part. So each gear is assembled on this hole It can be make you can use screw and all to assemble that, but Fusion 360 don't require that. So I'm just using these holes to locate the position of the gear on the table, and then I will going to give the relation between each gears. So for that, now here comes the tricky part. So for that, remember I have told you to check out the pitch diameter of each circle. What I'm going to do, let's take the example of these two here. So suppose that I am going to make this gear move to assemble with this orange one. So what I'm going to do is the dimension, the center dimension of the center point of these two gears can be calculated by combining the radius of both the pitch diameter. For example, if I just click measure and select the pitch diameter, the radius is 60, dia is 120, so 60. And if I just again click on this one, the radius here is 120, so 60 plus 120 is 180. So I'm going to make these two gears, the center distance from this point to this point should maximum or the minimum distance that is required to avoid the collision of the gears is 180 mm. And similarly you can calculate the radius here also, and this will be used to check the radius here. So I'm going to do is click on create a sketch, and on the front plane or the bottom plane draw a rectangle. For example, let me just draw a rectangle like this. Now again I will draw a circle of any diameter, let's say 10. Okay, 10 seems very small, let's say 20, and I am going to make another one 20 mm here. Now let's suppose that first I will be making this this gear, and then we will be using connecting this gear and this one and this one. So we will be moving towards the descending order, first the biggest one, then the smallest, then the last, the smallest one. So first of all I'm going to connect this pink one with the blue one. So if I just click on measure, you guys can see the radius of the pitch diameter. Pitch is 120. So 120 plus, if I just calculate the here is, it's 90. So 120 plus 90 is equal to 210. So what I'm going to do is press D for dimension and make the center distance between these two circles as 210. Once done, you guys can position it according to yourself. It is not necessary to position it in any way. So just fix this part like this. So you can rotate it like this anywhere you want. Now again, for example, we have calculated this one. Now it's time for the yellow one. So again, draw a circle of 20 mm. Now as you guys can see, if I just measure this, I forgot the radius. The radius was 90. And for the yellow one, the radius is 60. So 60 plus 90 is 150. So press D for dimension and make the distance between these two as 150. Once done. Now for the fourth one, as you guys can see, we are going to make the same thing. So this is 60 and this one is 30, so this is going to be 90. So press C for circle, make a circle and press D and make this dimension as 90 mm. Now once all your holes are okay, you may finish the sketch and extrude it. Go to solid, go to extrude and extrude it downward up to any distance, and this is going to be a new component. The dimension is not needed. We will be only using the holes here. So this is component 5. You can rename it as base. Once done, right click on the base and go to ground. So we have grounded the component. That means in any mean this cannot be moved. For example, I can drag this gear but I cannot this one. So this means this part is going to be the fixed one. So now I am going to place the pink one on here, then the blue one here, then the yellow one here, and the green one here on their each respective hole. So go to joints and it will ask you about the first component and snap the first point. There are two, the simple, the between two faces, and the third one is the two intersection. So first of all, I'm going to select the first snapping point. So just snap the top portion of this circle, and this is going to be fit on this part. Now as you can see, it's downwards, so just go to downwards and click on flip and go to motion and select the rotate. Select the rotate and the Z axis, and you can animate it to see the motion and press OK. Now if I just move, you can see it is now rotating on its axis. Now similarly repeat the same step for the second largest gear, the blue one here, and just go to downwards and flip it like this, as you guys can see. And just to check that you have calculated the pitch circle accurately, you guys can see if I just drag the teeth here, it is moving without having any collision, and yeah, this position is perfect. Okay, perfectly okay. Okay, one more point, just to, for example, just to avoid any more collision, for example, I have not taken any tolerance here. I have just calculated the radius of this one and created the bridge between these two. For example, if you just don't want if you don't want to have any extra collision and you just want to make your design with accurate tolerance, you guys can always, suppose that the distance from this point to this point was 210, that was theoretical, but in actual you should be using 210.25 or 0.5. At 100 or 200 micron tolerance would be enough to ensure no collision between two gears. But for now, for the theoretical concept and for the basic view, this seems okay. Let me just drag it and carefully here. Yeah, okay, they don't have any collision now. Now then repeat the same step for this one and here, and just go downwards and flip and okay, and repeat the same for the last one also. Select the center point and this one and flip it and okay. Now once done, what I'm going to do is go to top view and align each gear so that they don't collide with the teeth of another one. For example, I have aligned this one also. Now it's time for the yellow one to align. So just drag the yellow one so that it don't collide with the teeth of the blue one. Okay, this seems okay. Now repeat the same for the green one here also. Rotate the green one or any color that your Fusion 360 picked up so that it don't collide with the gear. Now that we have every gear in their desired position, just click on capture position to capture the position. Now I am going to link the gears between these two. Now we will start by making the smallest one. For example, the smallest gear here is T12 and the second largest is T24. So the number of the teeth on the yellow one is 24 and the smaller one has 12 teeth. That is exactly the half. So that means the gear ratio is 24 divided by 12, that is 2:1, that is 2 times. So that means for every revolution that green rotates, the yellow, okay, for that means that if the yellow one rotates 360 degree, the green one will rotate twice its time. That means it will rotate about 720 degrees. So for that, what I'm going to do is go to joints, and we have joint 4 and joint 3 that represents each joints, as you guys can see. So what I'm going to do is go to assemble and go to motion link, and I'm going to link the joint 4 with joint 3. Okay, so now the first is joint 1. Okay, so now let's see that for every 360 degree of rotation of one, we will be using the second one will be rotating by 720. Okay, we have just miscalculated it, so make its okay, this is the second one, this is the first one. That means the green one should be moving forward, so I'm going to make this 180 like this, and as you guys can see, they are rotating in different directions. So select the reverse. Now they are moving in a same direction. Now once done, now what I'm going to do is, if I just drag any the green one, the yellow one will automatically rotate. So what I have given it that 100-degree rotation of the green one will rotate 360 degree, exactly the 2 times of the green one, so that they will have the exact actual gear like movement. Now just revert back the position so that they gets back to their original position. Now the gear ratio of this, the number of teeth on the yellow one is 24, and on the bigger one is 36. So gear ratio, let me just open up the calculator, and the gear ratio this time is going to be 36 divided by 24. So 36 divided by 24. So gear ratio is 1.5. That means for any rotation the yellow makes, the blue will rotate 1.5 times less. So what I'm going to do is, the second revolution, second represents the blue one. So assemble, go to motion link, and we will be rotating the second to the third. Now if I just rotate 360 degree angle of the yellow, the blue one or the yellow one will rotate 360 degree multiplied by 1.5, and you may just press the OK, and 360 multiplied by 1.5, the gear ratio, as you guys can see, if I just drag it, it will each rotation that blue makes, the yellow one will make twice its rotation, and each rotation the yellow one makes, the green one will make the twice of it. So basically for each revolution that blue makes, the green will makes 4 rotation. So just revert the position for now. Again repeat this same exact step for the third one also. Now again this has 48 teeth, this has 36 teeth. So if I just open calculator and divide 48 divided by 36, so ratio is 1.333333. So 1.3 is the ratio. So just copy it like this, and again go to assemble, go to motion link, this time the one with the 2, and this time this is going to be 360 multiplied by control and paste. And if I just reverse it, okay, let me just check. Yeah, okay. So the things is okay. If you just sometimes you get confused between what to choose as the first revolution and the second. So basically this is a height and trial. You can always reverse the angle that you want. So basically if I just move like this, you guys can see that which every rotation that pink takes, the green will take up around 7.8 something revolution, which every revolution that is take. So basically it's a gear train that can be used in various purposes. So this video was to show you guys how to make a beautiful gear assembly and how to use the joints and how to use the complexity of the joints here. So hope you guys will enjoy. Do comment any queries and suggestions for my upcoming videos, and don't forget to share and subscribe. And also let me just show you the motion study also. So what I'm going to do is, for example, there is 2 ways to automate your system. For example, click on any revolution and right click on it and create on animate model. It will automatically be going and going and going and going till the time thus any key is pressed. So for example, this is revolution 1. This was revolution 1. So this is around 48 degrees. So what I'm going to do is, I'm going to make it 0 degree and press OK. Now the revolution 1 angle is at 0 degrees. Now I'm going to go to assembly, go to motion study. So what I'm going to do is, I'm going to create a motion study. So select the any joint. So let's say we have created the revolution 1 at 0 degree here. So select it. Now we have 100 points here to show you at which point it goes. So at the 100 point, I'm going to tell it that at the 100th point it should be rotating 360 degrees and press enter. Now from this point to this point, our pink gear will be rotating 360 degrees, and with respect to this is basically with a very simple motion study. This comes in handy when you are making a very complex assemblies. So if I just press play, you guys can see that it's playing around. and now there's an option called loop and play and backward. So I'm going to make it a loop video and just press OK, and it will keep on rotating and rotating and rotating, and you can increase the speed from here also. And if you are not a free Fusion 360 user, like I am a free, I'm not using a commercial license here, I'm just using an educating license. So if you are using a paid license, you can animate and render your motion study by going to the rendering workspace. I have already created a video on that, you guys can check that out in my video. Basically the motion study, if I just click on OK, you have an option for here. So this motion study can be rendered into a beautiful video. That is a paid feature, so you guys can check that out. So hope you guys will enjoy the video, and don't forget to share and subscribe. Thank you and have a nice day.